Welcome to this tutorial on debugging in JAX. Today we'll explore essential debugging techniques that can help you write better JAX code. We'll demonstrate everything using a Google Colab notebook, which provides an excellent environment for working with JAX. Since JAX performs exceptionally well on accelerated hardware, we'll use a TPU v5e environment for our notebook. After setting up our environment, we'll install JAX using pip, making sure to include the optional TPU components of the library. While JAX can be installed without TPU support, we'll use the full library to take advantage of all its features. In this tutorial, we'll focus on three powerful built-in JAX debugging methods: debug print, debug breakpoint, and debug callback. These tools are especially useful when you're working with just-in-time compilation or automatic vectorization, which can sometimes make debugging challenging. Let's begin with debug print, a helpful tool for debugging trace dynamic array values. While we can use Python's regular print function for static values like data types and array shapes, debug print offers special capabilities for working with the just-in-time compiler and automatic vectorization. To demonstrate this, we'll create a simple just-in-time compiled function. We'll start by using the just-in-time function decorator and include some normal print statements in our function. It's worth noting that these print statements are considered side effects, which means our function f of x is not purely functional. However, let's set aside this detail for now and try running the function with an input value of x equals 2. When we run this first example, we encounter an interesting problem. Instead of seeing the actual values, we only see trace time values. These traces indicate that the runtime values don't exist yet during the compilation phase. To solve that issue, we need to switch to JAX's debug print function. The debug print function uses string interpolation with its print statements, and when we use it, we'll see the actual runtime values instead of trace time values. We can further explore this concept using a vmap or vectorized map function. For example, we can create a range of numbers from 0 to 3 and apply vmap over our function using an array input. Since we vectorized x, we'll see the printouts of the y values. If we compare this to simply looping over our range normally, we'll notice that we get each pair of values one after another. This difference occurs because we're computing the same result in different ways, and when debugging, understanding these evaluation order details can be crucial. Next, let's explore the breakpoint function, another powerful debugging tool in JAX. This function allows us to pause the execution of our JAX program to inspect values, similar to how Python's PDB debugger works. The breakpoint function is actually built on top of the callback function and provides a way to examine both values and the call stack during execution. When using breakpoint, you can access various debugging commands. To see all available commands during a breakpoint debugging session, simply use the help command. Let's look at a practical example of how this works. When we run our code with a breakpoint, the execution pauses exactly where we defined it, and we enter the JDB debugger in our notebook. After entering the debugger, we can use different commands to inspect our program state. For instance, we can use the L command to see our current position in the code. We can also examine specific values. In our example, we can see that y has a value of 0.9 and x has a value of 2. When we're done inspecting values, we can use the C command to close the debugger and continue execution. Sometimes we want to pause execution only under certain conditions. For these situations, we should use the lax conditional function to create conditional breakpoints. Let's demonstrate this with a division example. If we divide 2 by 1, everything works normally and we won't hit a breakpoint. However, if we try to divide by 0, our debugger will be triggered. This is particularly useful when you have silent failures in your code and want to automatically pause execution when they occur. To better understand how JAX handles these conditional breakpoints, we can use the makeJAXPR function to visualize our JAX expressions. This shows us that the conditional statement is properly reflected in the code with our debug callback placed in one of the conditional branches. Finally, let's discuss the callback function, which provides even more control during debugging. The callback function is actually the foundation for both debug print and debug breakpoint, making it a fundamental part of JAX's debugging toolkit. Let's examine this with another example. Callbacks give us the ability to inspect values during JAX function execution in a more flexible and powerful way than the other debugging methods. One of the most impressive features is that we can perform this value inspection even with just-in-time compiled code, which don't cleanly accommodate side effects like logging. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include a link to the JAX debugging documentation in the description as well. If you have any questions, please post them in the comment section and we'll do our best to respond. Thank you very much for watching to the end, and please enjoy responsibly.